Hello everybody, I am Aarti Yadav from Department of Dairy Science and Food Tech, Banaras Hindu University. So today I am gonna give you an overview of infrared heating. So let's begin with our presentation. So infrared radiation was discovered by William Herschel in 1800, and he discovered this during the process in which he was using thermometer for measuring the temperature of the spectrum of light passing through the prism. So infrared radiation is EM energy which falls between the region of visible light and microwaves, and therefore infrared radiation is defined as that part of EM spectrum whose wavelength ranges from 0.78 to 1000 micrometer. Most of the thermal radiation emitted by objects near room temperature is usually infrared. The image which you are seeing in the extreme left of this presentation slide, it shows when the person is exposed to infrared radiation, how does it appear. Infrared is divided into three types: near infrared, mid infrared and far infrared. So near infrared wavelength ranges from 0.78 to 1.4 micrometer. Mid infrared wavelength ranges from 1.4 to 3 micrometers, and far infrared wavelength ranges between 3 and 1000 micrometers. You can see in this image, it is very clearly evident. Now moving on to the principle of infrared heating. So when a food molecule is exposed to infrared radiation, some of the radiation is reflected, some of it is transmitted, and some of it is absorbed. So when the radiations which are absorbed leads to the movement of moisture from the core towards the outer sides, which lead to proper and uniform heating of the food molecule. And this other image on the right hand side, it shows the energy balance on a thin layer of rough rice which is exposed to infrared radiation. So this picture evidently depicts that after the infrared radiation is incident on the grain layer on the insulated tray, there it is dissociated into many radiations such as reflected, emitted, convected, and some of it is evaporated. Now coming to the mechanism of infrared heating. So infrared heating utilizes radiative and conductive heat transfer mechanisms to generate and transfer heat. And when infrared radiation is incident on a food surface, it penetrates directly into the sample and impinges on the surface of material which has to be tried. So EM waves cause thermal movement of the molecules, rotational movement, and the vibrational movement of internal atomic bonds of the food product. Vibrational may also be referred to as stretching. So absorption of EM waves increases the molecular vibration inside the material and results in heat generation in both inside and surface of the material concurrently. This was found in research. So after the absorption of EM waves, the molecules excited by the vibratory movement continuously lose energy in random directions as a result of collisions between the molecules. So this transfer energy to the surrounding environment as well in the form of heat, and in this manner the whole product is uniformly heated. So this image on the left hand side, it shows the heat distribution comparison with respect to conventional heating and infrared technology. So in the conventional heating, you can see that there is a heat flow in the food product in a particular direction. There is no uniform flow, and each product does not receive equal amount of heat. But in the infrared technology, you can see that each product is exposed to radiation in an equal manner and in a uniform manner, and therefore there is uniform heating achieved in infrared technology. And the image on the right hand side, upper right hand side, it shows that in conventional heating, the problem of case hardening may occur because as the food molecule is exposed to heat, there is mass transfer, but heat is accumulated in the food product. Whereas in infrared heating, when the waves are incident on the food product, heat and mass, there is both transfer of heat as well as mass, which results in uniform heating and no case hardening. The problem of case hardening does not occur. And the image below it shows how it shows that the penetration of infrared is limited to a certain depth, and it does not penetrate to the core of the food product. Now, let's see the interaction of infrared with various food components. So, the food materials can be considered as complex matrices consisting of different biochemical macromolecules, biological polymers, inorganic salts, and water. So, during infrared heating, the food objects can absorb radiation at certain wavelength, reflect and transmit radiation at another wavelength. So, the image on this right hand side, it shows the various absorption wavelength of proteins, lipids, sugars with respect to water. The continuous line which you are seeing here, it is of water. So absorption of proteins by IR radiation is at wavelength 3 to 4 and 6 to 9 micrometer. Fat absorption is at wavelength 3 to 4, 6 and 9 to 10 micrometer. Sugars absorption is at 3 and 7 to 10 micrometer. The water absorption beams are at 3, 4, 7, 6 and 15.3 micrometer. So, and moreover, infrared radiation helps to reduce beta carotene chlorophyll degradation in the heating process, and IR is more effective for pasteurization than non-infrared, killing bacteria and spores. Now moving on to the emitters, which are responsible for emitting the infrared radiation. So the classification of emitters based on the energy source. So emitters are classified as electrical emitters and gaseous type emitters based on the energy source. So electrical emitters, these produce infrared radiation in the range of 1100 to 2200 degrees Celsius, and gaseous type emitters, these produce infrared radiation in a range of 343 to 1100 degrees Celsius. And the electrical emitters, these are operated electrically. There is a metal filament which is enclosed with a evacuated material or which is filled with inert gas, and the electric current is passed through the metal filament. Whereas in the gaseous type of emitters, these are powered by propane or natural gas. The electrical type emitters are more widespread because of their ease of control, fast heating rate and clean energy, so because they act as a clean energy source, whereas the gaseous type emitters have relatively less availability. The operating cost of electrical emitters are high, but the operating cost of gaseous type emitters are relatively low, but the initial cost is very high. The conversion efficiency is 78% to 85% in electrical emitters and is 40 to 46% in that of gaseous type emitters. Electrical type emitters consist of incandescent lamps, quartz tubes, and the gaseous type emitters consist of direct flame infrared radiators, ceramic burners, metal fire burners. Now moving on to another criteria of classification, that is the based on wavelength. So on the basis of wavelength, emitters are divided into three types, that is short wavelength, medium wavelength and long wavelength. So short wavelength consists of 0.7 to 1.4 micrometer, medium wavelengths are from 1.4 to 3 micrometers, and long wavelength emitters these consist of 3 micrometers wavelength. So the color of the radiation is bright white in case of short wavelength, it is bright orange in case of medium, and it is dull orange in case of long wavelength. And The common applications in short wavelength are powder coatings, adhesive bondings, metal castings, preheatings, and in medium it is drying and curing of food products, and in long it is required in processes of convection infrared heating. So there are many other aspects of classification you can see here. Now moving on to the advantages and limitations of infrared heating. So firstly, the advantages. So infrared heating requires less drying time. It is highly energy efficient. It offers uniformity in drying. It offers homogeneity in heating. There is high heat transfer rate. It improves the quality of the treated product. It improves the safety of the treated product, and it has high controllability. It reduces the consumption of chemicals and water and also increases manufacturing efficiency. It does not produce volatile organic compounds such as carbon monoxide and nitrogen oxides. It does not need heat recycling. It does not need an isolated system. And it preserves vitamins and has very little flavor loss, and the temperature of the surroundings, it is not affected. Now moving on to the limitations. So uh, there was one limitation which I had discussed before, that is it has low penetration power. Prolonged exposure may cause fracturing tissue, causing rupture in biological materials, thus causing nutritional deficiency sometimes. And it has infrared offers insensitivity to the reflective properties of the coating. Now coming to the applications of infrared heating. So there are many applications. Some of them are written here, such as browning of meats and other foods, roasting nuts, which I've shown on the right in the picture on the extreme top corner right hand side. These are also used in decontamination and disinfection of food and food contact surfaces. These are also used for microbial inactivation. Infrared peeling of tomatoes are shown in the below right corner. Infrared drying, it is the major application. Baking of breads and baked goods, infrared blanching, pasteurization, drying and dehydration. So infrared blanching, this towards the extreme left below corner of this slide, you can see that there is infrared blanching of pear done, and it just took 2 minutes for that process to be completed. Now coming on to some investigations which were done on infrared. So there were two investigations, and these two offered contrasting results. So first investigation was done by drying the pumpkin at temperature of 55, 65, 75 and 85 degrees Celsius, and its effect was seen on the pumpkin. So according to the results, with increasing temperature from 55 to 85 degrees Celsius, the drying time decreases by about 60%, and the effective diffusion coefficient increased by 140%. And another investigation which was done, it was done on the rice bran. So as we all know, rice bran, which is high water content, free fatty acids, vitamin E, and gamma oryzanol content. So when the research was done on rice bran, so it showed that infrared heating affects the water content of rice bran, reducing its shelf life, and additionally the infrared exposure produced an insecticidal effect in the rice bran. So these two investigations offered contrasting results. Now moving on to the safety of infrared radiation. So according to the current research on infrared radiation, it shows that IR is not powerful enough to alter the molecule structure of food, cooked using it as a heat source, and its food results are safe for human use and consumption. Now coming to some other researches which was done. So first research, the effect of infrared temperatures was studied on total phenols of the orange peels and leaves. So the first graph which you are seeing, it shows that the fresh leaves and peels, these have the highest phenolic content, which phenols are responsible for antioxidant activity. So as you can see in the picture, when the peels and the leaves were exposed to infrared heating at higher temperatures, there was more phenolic content, but at lower temperatures such as 40 to 50, there were less of phenolic content, because at higher temperatures the phenols resist thermal breakdown. So at higher temperatures the antioxidant activity of the orange peels and leaves were restored. Now coming on to the another research, which was in this, the changes in peroxide value of roasted almonds with infrared and infrared with hot air during storage at 37 degrees Celsius was studied. So after 3 months, it was seen that the at 130 degrees Celsius the peroxide value was 1.59. At 140 degrees Celsius the peroxide value was 12.10, and at 150 degrees Celsius the peroxide value was 36.07. So these results were of combination of infrared and hot air. So according to the current data, the peroxide value should be nearly 5 milliequivalent per kg. So we can conclude that infrared radiation at 150 degrees Celsius gives higher peroxide value and higher oxidation rates, and this is due because infrared penetrates almonds quickly and causes fat to move to the surface exposed to high temperature. Thus, it causes rapid oxidation. So, best conditions for roasting is when we are using hot air. The temperature should be 130 to 150 degrees Celsius, and when we are using infrared, the temperature should be 130 degrees Celsius. And these temperatures increases the duration of storage to 4 to 5 months at 37 degrees Celsius. So there was another research which done. In this, there was a comparison between conventional heating and infrared heating of juice. So first graph, it shows that the time required to reach the highest temperature, that is the 90 degrees Celsius for juice. In conventional heating, it requires 6 minutes, whereas the time required to reach 90 degrees Celsius in infrared heating, it requires 3.5 minutes. So we can see that in conventional heating, almost double the time is taken. So the nutritional quantity in infrared heated juice will be obviously more. And moreover, the D value of conventional heated juice is less as compared to the infrared heated juice. D value refers to the time required to destroy 90% of ascorbic acid present in the juice. So infrared heated juice is much more preferred as compared to the conventional heated juice. So now coming on to the hybrid infrared system. So the first image, it shows infrared blanching and hybrid drying system. So in this, infrared is combined with the hot air or cold air, and in this manner there is efficient drying of the food product. And the second image, it shows the infrared and microwave combination oven. So it serves microwave heats the food quickly, and infrared increases the tanning and crisping reactions. So in this manner there is a desirable food quality and the sensory value also increases of the food product. Now coming on to the benefits of hybrid infrared in roasting. So when infrared are combined with microwaves, so it reduces roasting time. The quality is very much similar to that achieved in the conventional method, and the color achieved is very much desired, and this is the new promising technology This is an effective alternative method as well, and it is recommended technology for roasting. And when infrared radiation is combined with hot air, it reduces the roasting time, the production of high quality product. There is low energy consumption. It is a novel, promising technology, and this is an effective alternative method, and it is suitable for industrial scale application. Now, last but not the least, moving on to the conclusion. So, IR heating utilizes radiative and conductive heat transfer mechanisms to generate and transfer heat. So, radiation heating occurs at the surface and conductive heating occurs on the inside of the food. Okay, so infrared drying is a promising novel method and has attracted a lot of attention for surface heating applications such as prevention of growth of yeast and fungi on cheese surfaces, pasteurization of the surface of eggs, as well as ready-to-eat meats such as hot dogs, arresting fungal spoilage of strawberry during storage, as well as dry pasteurization of raw almonds. The development and implementation of IR technologies in the food and agriculture sectors as an alternative and sustainable methods will benefit the environment and reduce energy and water use. And the need for improved product quality, safety, and energy and processing efficiency are expected to drive the industrialization of IR technologies for food and agriculture processing. IR heating is attractive primarily for surface heating applications in order to achieve energy optimum and efficient practical applicability in the food processing industry. Combination of IR heating with microwave and other conductive and convective modes of heating, such as combination with hot air, holds a great potential as it heats food quickly and eliminates the problem of poor quality. And it is quite likely that the utilization of IR heating in the food processing sector will augment in the near future, especially in the area of drying and manual processing. That's all for now. I am open to all the suggestions if there are any. Thank you so much for listening.